Good morning friends, I am Ranjit Dhunde. Welcome back to the lecture series on the topic Laplace Transform. In the previous lecture, we have already discussed inverse Laplace Transform by using partial fraction method, by convolution theorem and by using properties. In this lecture, we will focus on application of Laplace Transform, and one of the application of Laplace Transform is to solve linear ordinary differential equations. The Laplace transform method is a powerful method for solving linear ordinary differential equations and corresponding initial value problems. The process of solution consists of three steps. Number 1, the given ODE is transformed into an algebraic equation by applying Laplace transform. The Laplace transform converts this ODE into an algebraic equation. So this is step 1. Now step 2, solving algebraic equation. Solving algebraic equation by using purely algebraic calculations. And third step, inverting the solution of algebraic equation, we get the desired solution of the given ordinary differential equation. Inverting the solution of algebraic equation. For this technique, we recall the Laplace transform of derivatives. Recall Laplace transform of f prime of t means Laplace transform of d by dt f of t, and this is equal to s times f bar s minus f of 0, and Laplace transform of f double prime of t is equal to Laplace transform of this double prime denotes the second order derivative of f of t, so d2 by dt square f of t is equal to s square f bar s minus s f of 0 minus f prime of 0. Now we denote this f of t is equal to y of t. Now let f of t is equal to y of t, and therefore this Laplace transform of f prime of t means y prime of t is equal to Laplace transform of d by dt y of t is equal to s times f bar s, means now y bar s, because f bar s be the Laplace transform of f of t, so y bar s be the Laplace transform of y of t, minus f of 0, the answer is y of 0, means replace this f by y. Now Laplace transform of this y double prime of t, that is Laplace transform of d2 by dt square y of t is equal to s square y bar s minus s y of 0 minus y prime of 0. Now let us discuss this Laplace transform method with some example. Example 1, solve y double prime means d2y by dt square minus y is equal to t with given initial condition y of 0 is equal to 1 and y prime of 0 is equal to 1 by Laplace transform method. Now solution, so by applying Laplace transform to both sides of the given differential equations, by applying Laplace transform to both sides of the given differential equation, so therefore Laplace transform of y double prime minus Laplace transform of y is equal to Laplace transform of t. Now Laplace transform of y double prime, the answer is s square times y bar s minus s times y of 0 minus y prime of 0, minus Laplace transform of y means Laplace transform of y of t, and answer is y bar s and is equal to Laplace transform of t. The answer is 1 upon s square. Now this is the algebraic equations in the form of this y bar s. Now using the given conditions are the y of 0 1 and y prime of 0 is equal to 1. So using y of 0 is equal to 1, y prime of 0 is equal to 1. The answer is s square y bar s minus s, y of 0 be the 1, the s times 1, minus y prime of 0 be the 1, minus y bar s is equal to 1 upon s square. Now here this y bar s be the common term, so therefore answer is s square, this minus 1 times y bar s, this minus s minus 1 is equal to 1 upon s square. So therefore s square minus 1 y bar s is equal to this 1 upon s square. Now here minus s, so therefore here becomes plus s, this minus 1 here becomes plus 1. Now dividing this whole equation by s square minus 1, so therefore this y bar s is equal to 1 upon s square times s square minus 1 plus this s plus 1 divided by s square minus 1. Now we resolve this fraction into partial fraction. But for simple calculation, I am going to tell you some easy tricks for partial fraction. Now here this one be the difference of these two factors s square minus 1. So therefore we write this one as s square minus 1 upon s square times s square minus 1 plus this s plus 1, and here this s square minus 1 means s minus 1 times s plus 1. Now dividing this first term s square by s square times s square minus 1, so this is equal to this s square get cancelled, the answer is 1 upon s square minus 1, minus dividing this s square minus 1 by denominator means s square times s square minus 1, so this s square minus 1 get cancelled, the answer is 1 upon s square plus, now here s plus 1 get cancelled, the answer is 1 upon s minus 1. So this is the y bar s. Now using inverse Laplace transform to both sides, the inverse of y bar s is equal to inverse of 1 upon s square minus 1 minus inverse Laplace transform of 1 upon s square plus n inverse of 1 upon s minus 1. Now inverse Laplace transform of y bar s, we get y of t is equal to inverse Laplace transform of 1 upon s square minus 1, answer is sin ht, sin hyperbolic function of t, minus inverse Laplace transform of 1 upon s square, answer is t, and inverse Laplace transform of 1 upon s minus 1, the answer is e to the power t. So this is the required solution for the given ordinary differential equations. Now second example, solve y double prime plus 2 times y prime plus 5 times y is equal to e to the power minus t times sin t with given condition y of 0 is equal to 0, y prime of 0 is equal to 1. Now in solution, by applying Laplace transform to both sides of the given differential equations. So therefore Laplace transform of y double prime plus 2 times Laplace transform of y prime plus 5 times Laplace transform of y is equal to Laplace transform of e to the power minus t sin t. Now Laplace transform of y double prime is equal to s square y bar s minus s times y of 0 minus y prime of 0 plus 2 times Laplace transform of y prime. The Laplace transform of y prime, answer is s times y bar s minus y of 0 plus 5 times Laplace transform of y. The Laplace transform of y, answer is y bar s. Now this is equal to Laplace transform of e to the power minus t times sin t. So now Laplace transform of sin t, answer is 1 upon s square plus 1. Now by using the cost shifting property, Laplace transform of e to the power minus t sin t is equal to 1 upon s plus 1 whole square plus 1. So therefore Laplace transform of e to the power minus t sin t, answer is 1 upon s plus 1 whole square plus 1. Now by using the given initial conditions, using y of 0 is equal to 0, y dash of 0 is equal to 1. So therefore this is equal to s square y bar s minus this y of 0, 0 means s times 0, y dash y prime of 0 1, here answer is minus 1 plus 2 times s y bar s minus 2, again this y of 0 be the 0, the 2 times 0 plus 5 times y bar s is equal to 1 upon s plus 1 whole square plus 1. Now here y bar s be the common term. So therefore s square plus 2 times s plus this 5 times y bar s. Now this is the 0, this is also 0 and this minus 1. Therefore answer is s square plus 2 times s plus 1 means 2, and this minus 1 in this side, this is the plus 1. Now dividing this whole equation by s square plus 2 times s plus 5, we get y bar s is equal to 1 upon this s square plus 2 times s plus 5 times this s square plus 2 times s plus 2 plus this 1 upon s square plus 2 times s plus this 5. Now for partial fraction I am going to tell you easy tricks. So now this 1, so now difference of these two factors s square plus 2 times s plus 5 minus s square plus 2 times s plus 2, the answer is 3. But therefore this s square plus 2 times s plus 5 minus s square plus 2 times s plus 2, its answer is 3, and here is 1. So therefore we are balancing this 3 by dividing by 3, means 1 by 3 upon s square plus 2 times s plus 5 times s square plus 2 times s plus 2 plus 1 upon s square plus 2 times s plus 5. Now dividing this first term by the denominator and minus second term by the denominator, the answer is 1 by 3, and dividing this first term by the denominator, this s square plus 2s plus 5 get cancelled, the answer is 1 upon s square plus 2 times s plus 2 minus now second term divided by the denominator, this here s square plus 2s plus 2 get cancelled, the answer is 1 upon s square plus 2 times s plus 5 plus 1 upon s square plus 2 times s plus 5. Now this is equal to 1 by 3 times 1 upon s square plus 2 times s plus 2 minus, now minus 1 by 3 times 1 upon s square plus 2s plus 5 plus 1 upon s square plus 2s plus 5, the answer is minus 1 by 3 plus 1, that is equal to 2 by 3. So therefore answer is plus 2 by 3, 1 upon s square plus 2 times s plus 5. So therefore y bar s is equal to this 1 by 3 and 1 upon s square plus 2s plus 2, it's s plus 1 whole square plus 1 plus this 1 by 3 and 2 is here, s square plus 2s plus 5, this is the s plus 1 whole square plus 4 means 2 square. Now by applying the inverse Laplace transform, the inverse Laplace transform of y bar s is equal to 1 by 3 L inverse of 1 upon s plus 1 whole square plus 1 plus 1 by 3 L inverse of 2 upon s plus 1 whole square plus 2 square. Now L inverse of y bar s, answer is y of t. This is equal to 1 by 3. Now by using the shifting property for inverse Laplace transform, its inverse be the e to the power minus t times sin t plus 1 by 3. Again its inverse be the e to the power minus t times sin 2 times t. Therefore y of t is equal to 1 by 3 times e to the power minus t times sin t plus sin 2 times t. So this is the required solution for. Now third example, solve dy by dt plus 2 times y plus integration 0 to t y dt is equal to sin t and given condition y of 0 is equal to 1. Now solution, by applying Laplace transform to both sides of the given differential equation. Therefore Laplace transform of dy by dt plus 2 times Laplace transform of y plus Laplace transform of integration 0 to t y dt is equal to Laplace transform of sin t. Now Laplace transform of dy by dt means Laplace transform of y prime, answer is s times y bar s minus y of 0 plus 2 times Laplace transform of y, the answer is y bar s plus Laplace transform of integral, we recall the property Laplace transform of integral 0 to t f of u du is equal to f bar s upon s. So therefore Laplace transform of this integral, answer is y bar s upon s is equal to Laplace transform of sin t, answer is 1 upon s square plus 1. Now simplification, by using this given condition y of 0 is equal to 1 and here y bar s be the common term, the answer is s plus 2 plus 1 upon s y bar s, and this y of 0 be the 1, the minus 1 is equal to 1 upon s square plus 1. Now cross multiplication, s square plus 2 times s plus 1 upon s times y bar s is equal to 1 upon s square plus 1, this minus 1 in this side, this is the plus 1. Therefore this y bar s is equal to s upon this s square plus 1 times this s square plus 2 times s plus 1 plus s upon s square plus 2 times s plus 1. Now we resolve this fraction into partial fraction by using easy trick. So therefore this is equal to, now difference of these two factors, so s square plus 2 times s plus 1 minus s square plus 1. Now its answer is 2 times s. So here answer is yes. So balancing these two, so by using this 1 by 2, upon this s square plus 1 times s square plus 2 times s plus 1 plus this s upon this s square plus 2s plus 1, the answer is s plus 1 whole square. Now dividing this first term by the denominator and second term by the denominator, so we get this 1 by 2, and here this first term get cancelled, the answer is 1 upon s square plus 1 minus this 1 by 2, and here this s square plus 1 get cancelled, the 1 upon s square plus 2 times s plus 1 plus, now here s upon s plus 1 whole square, so we are adjusting this s as s plus 1 minus 1 upon this s plus 1 whole square. Now this is equal to 1 by 2, 1 upon s square plus 1 minus 1 by 2, and this s square plus 2s plus 1 is the s plus 1 whole square plus, now dividing this first term by the s plus 1 whole square and second term by the s plus 1 whole square, the answer is this s plus 1 get cancelled, the answer is 1 upon s plus 1 minus 1 upon s plus 1 whole square. Therefore, y bar s is equal to this 1 by 2, 1 upon s square plus 1. Now here minus 1 by 2, 1 upon s plus 1 whole square. Now here minus 1, 1 upon s plus 1 whole square. The answer is minus 1 by 2 minus 1 minus 3 by 2, 1 upon this s plus 1 whole square plus 1 upon s plus 1. Now by using inverse Laplace transform, the inverse of y bar s is equal to half L inverse of 1 upon s square plus 1 minus 3 by 2 L inverse of 1 upon s plus 1 whole square plus L inverse of 1 upon s plus 1. Now inverse Laplace transform of y bar s, answer is y of t is equal to half inverse of 1 upon s square plus 1, answer is sin t minus 3 by 2. Now by using the shifting property for inverse Laplace transform, inverse of 1 upon s plus 1 whole square, answer is e to the power minus t times t plus inverse of 1 upon s plus 1, answer is e to the power minus t. So this is the required solution for the given differential equation. From these three problems, we conclude that the Laplace transform method have certain advantages over the usual method, because the solution of the given differential equation can be found directly without first determining the general solution of the given ordinary differential equation, and in terms of non-homogeneous differential equation without first solving the homogeneous differential equations. So hope all of you have understood this topic. Stay safe, stay healthy. Thank you. Have a nice day.